Dear students, in this video, I am going to discuss about interaction of radiation with the matter. Okay, so for the better understanding, please watch the previous video, that is introduction to laser part. So now let us get into the video of interaction of radiation with matter. So what is this interaction of radiation with matter? So radiation is nothing but light. Radiation is nothing but light. Okay, when the light is falling on the matter, so matter may be solid, liquid, gas, or anything. So all these things consist of atoms. Okay, for example, solid means the atoms are closely packed. Okay, and liquid means comparatively with this it is loosely packed, and then gas, it is very loosely packed. This is what the differentiation between solid, liquid, and gas. So matter means it may be the kind of any one, solid, liquid, or gas. When the light is falling on this matter, so what kind of interactions will takes place? So this is what we are going to discuss in this topic, interaction of radiation with the matter. First, I am going to explain about there are three main phenomenon takes place when the light is falling on the matter. What are the three main phenomenon? The first phenomenon is called the first phenomenon is absorption. The first phenomenon is absorption, and the second one is emission. Second one is emission. The emission are of two types. Okay, the first one is spontaneous emission. Spontaneous emission. And the second one is stimulated emission. Stimulated emission. So as we know well, the abbreviation of laser is light amplification by stimulated emission of radiation. So the third one is very important for the laser production. So that is the reason we are talking about this topic, interaction of radiation with matter. When the light is falling on the matter, these three phenomena takes place. First one is absorption, second one is spontaneous emission, and the third one is stimulated emission. So let us discuss each and everything in detail. So first I am going to explain about absorption process. So what is absorption process? Absorption process. Okay, so already we have discussed about how the light is produced. Okay, so in between the two energy levels, okay, the lower energy level is called, this is the lower energy level. So here, based on the energy only we are talking. So though in the graph which is at the last, that means which is in the lower part, so it is called lower energy level. Lower energy level, or it is also named it as ground state. Ground state, which is represented by the letter E1. E1. Okay, ground state is represented by E1. The higher energy. Now you see this is the lower value of energy. So this is called lower energy level. This is the higher energy. That is what it is called, higher energy level. This higher energy level also known as excited state. Excited state. Here the energy can be represented as E suffix 2, E2. This is E1 and this is E2. Generally the atoms will present in this. The atoms present in this ground state. Okay, the atoms present in the ground state. So when now we are talking about the interaction of radiation. So radiation is nothing but light. Light is made up of photons. Already we know that. So light is made up of photons. So photons are the small particles of the light, right? So when the light is incident on, so you see here, this is the photon. This photon is incident on this atom in the ground state. When the photon is falling on that, so the photon is incidenting on this atom gains sufficient energy from the photon, and then it will jump to the excited state. It is jumping into the, it is transferring from lower energy state to the higher energy state. So this process is called absorption. Okay, so how the photons will be created, that means from externally we are supplying the energy. Okay, so this is external source, we can say. It may be by means of heat we can give, okay, or light, even through electrical field also, right? But in this case, what is the title? Interaction of radiation with the matter. So here we are talking about the light. So light is made up of small particles, which is nothing but photons. This photons is falling on the atoms in the matter. So this atom absorbs the energy and then it is jump into the higher state. Okay, from ground state to higher state. So the atom transition takes place in this case. So the atom transisted from lower energy state to the higher energy state, or ground state to the excited state. So this process is called absorption. So how can we define absorption? Absorption is the process. Absorption is the process by which the electrons in the ground state jumps into excited state by gaining energy from the external source, so when the radiation is falling into the matter, this what happens, absorption takes place. So here what is the sufficient energy? So whatever the light is falling on that, the atom never goes to the excited state. So what is the condition when the absorption takes place? When the photon is having the energy, that is photon energy should be equal to the difference between the two energy states. What is the difference between two energy states? E2 minus E1. Okay, then only the atom gains energy and then it will go to the excited state. So this is the condition. Okay, how much energy to be supplied for the absorption process means the supplied energy will be the difference between the two energy states, that is excited state and the ground state. So E2 minus E1, then only the atom absorbs energy and then it will go to the excited state. Okay, so this is the first phenomenon. Next we are going to discuss about spontaneous emission. Okay, so this is the absorption process over. Now we are going to talk about the spontaneous emission process. Spontaneous emission. Okay, spontaneous emission. Again we are going to talk about the same energy states. So simply I am writing E1 and E2. E1 is the ground state and E2 is the excited state. Currently the atom, that means absorption process over. Now the atom is present in the excited state. So how long the atom can stay there in the excited state? Actually the atom can stay only for the short period. It can stay only for the short period of time. So the time, how much, that means how much time the atom stays in the excited state is called, that is lifetime of the atom. The time up to which the electron stays in the excited state is called the lifetime of an electron or lifetime of the atom. So which is equal to 10 power minus 8 seconds. How much time it can stay there? 10 power minus 8 second. So this is the lifetime of an atom in the excited state. Once the lifetime is over, automatically this atom will jump into the ground state. Okay, it will come to the ground state. By the time it emits photons, that is H nu, it emits photons, right? So this process is a natural process. It is the natural process. Okay, so automatically once the lifetime of the atom is over in the excited state, that is what the lifetime time is 10 power minus 8 seconds, automatically the atom in the excited state come back to the ground state by emitting the photon. The process is emission, right? By emitting the photon h nu. Okay, so how much energy it will emit? E2 minus E1. Okay, so it will emit the energy and then it will come back to the ground state. So this process is called spontaneous emission. Okay, this process is called spontaneous emission. So this is the natural process, and moreover we won't have any control on this emission. We cannot control. This is the natural process. So this is called spontaneous emission. So now we will have idea about the spontaneous emission. Okay, so next we are going to talk about, okay, I will write here the definition for spontaneous emission. It is the process, it is the process by which the excited atom jumps to ground state by releasing or by emitting. Okay, mainly it is emitting, right? By emitting photon naturally. By emitting photon naturally. Okay, so it is the process by which the excited atom jumps to the ground state by emitting photon naturally. Okay, so this process is spontaneous emission. So next we are going to talk about stimulated emission. This is what important for the laser production. Okay, stimulated emission. Stimulated emission. Okay, emission means from higher state to lower state. Okay, stimulated emission. So again we are going to consider the two energy states. This is the lower energy state and this is the higher energy state, that is the ground state, and higher, that is excited state. Currently the atom is present in the excited state. We are talking about the emission. So emission means it should be in the excited state only, right? So now in this case the incident photon is involving. Okay, in previous case, in spontaneous emission, naturally it happens. Once the lifetime is over, the atom jumps to the ground state automatically, naturally. But in this case the photon is involved. Which photon? The incident photon is involved. Incident photon is involved. What the incident photon is doing? This incident photon go and trigger or stimulate. This is what? Okay, so stimulate the atom in the excited state. So by stimulating before the lifetime, okay, this atom should not stay for a longer time, that is a 10 power minus 8 second. It should not wait there. Okay, so this photon interact with the atom in the excited state and make them to come back to the ground state. So by the time two photons will be released. One is the incident photon, okay, and another one is the atom emits energy from excited state to ground state. Okay, when it transfers from excited state to ground state, it releases energy, right? So now you see these two photons will be in the same direction. As not only in the same direction, listen carefully, it emits photons in same direction and then same frequency. It will maintain the same frequency, same wavelength, and the same phase also. That is very, very important. Same phase. Okay, and moreover same direction. The photon emitted, which is in the same direction as that of the incident photon. So this process is called stimulated emission. In previous case only one photon is emitted, but here two photons are emitted. Why? Because the incident photon is involving in this case. Okay, so this process is the artificial process. This is the artificial process, right? In previous case, that is the spontaneous emission is the natural process, but it is the artificial process. So before the lifetime, the photon triggers or stimulates the atom in the excited state to come back to the ground state. By the time two photons are released, one is incident photon and another one is the photon emitted by the atom in the excited state to ground state. So the two photons have the same direction or moving in the same direction. It maintains the same frequency, wavelength, as well as same phase. Okay, so this process is the artificial process, and moreover we can control the process also. Okay, but if the spontaneous one is random and uncontrollable process, but stimulated emission is the artificial process and it is controllable. Okay, so this process is important for the laser production. So now let me write the definition for stimulated emission. It is the process by which the incident photon stimulates the atom in the excited state to jump into ground state. So who is involved here? Incident photon is involved. It is the process by which the incident photon stimulates the atom in the excited state to jump into the ground state. So what is the result of this process? It produces two photons. Okay, these two photons will have the same that means both are identical. Okay, in what way both are identical? It emits in the same direction, it has the same frequency, wavelength, and also the same phase. Okay, so this is what you have to understand when the light is in, that is when the radiation is interacted with the matter. Okay, so I hope you understand everything. If you have any doubt, please ask me in the comment section. Thank you everyone.